Good morning. This recording is for Algebra 1, Chapter 10, Lesson 3, and we're talking about operations with radicals. So, like radicals have the same radicand, and unlike radicals have different radicands, basically the stuff that's inside. And we're going to use the distributive property to combine like radicals. All right, so combining like radicals. Square root of 2 plus 3 times the square root of 2. Well, there is an invisible 1 in front of that first square root of 2, which means if I have 1 square root of 2 and 3 square root of 2's, it means I have a total of 4 square root of 2's. Pretty cool, huh? All right, so if I have a square root of 10 minus 5 times the square root of 10, well, I have 1 square root of 10 minus 5 square root of 10, which means I'm going to end up with negative 4 square root of 10. All right, moving on. All right, so you may need to simplify radical expressions to determine if they actually have like radicals. And obviously you just simplify first. So if I have 3 times the square root of 2 plus 2 times the square root of 5, I can break that square root of 20. That's a square root of 3 times the square root of 20, not the square root of 2. Square root of 20 into 5 times 4. Pull out the 4, and I end up with 6 times the square root of 5 plus 2 times the square root of 5, and I end up with 8 times the square root of 5. That's it. All right, number 2, if I have 3 times the square root of 3 minus 2 times the square root of 27, 27 can be written as 3 cubed, so I can pull out a square root of 3, or the square root of 9, and there we go. I end up with 3 times the square root of 3 minus 6 times the square root of 3. 3 minus 6 is negative 3, and I end up with negative 3 times the square root of 3. All right, so simplifying products and quotients. So distributive property with radicals is like Angry Birds. So I'm just going to Angry Bird everything, distributive property. So the square root of 5 times 2 is 2 times the square root of 5 plus the square root of 5 times the square root of 10. And I'm going to end up with 2 times the square root of 5 plus the square root of 50. Break up 50 to simplify, and I end up with 2 times the square root of 5 plus 5 times the square root of 2. Next question. Oh, remember you cannot combine unlike radicands or radicals. All right. So next question, the square root of 2x times the quantity square root of 6x minus 11. Distribute. Square root of 2x times the square root of 6x minus 11 times the square root of 2x. All right, that leaves me with the square root of 12 times x to the second minus 11 times the square root of 2x. And I can pull out a 4x squared, which is going to leave me 2x times the square root of 3 minus the square root of 2x. And it's simplified as far as it can go. All right, next problem. The square root of 5a times 5a plus 3. Distribute. And I end up with the square root of 5a times the square root of 5a, which is just 5a. Or at least the square root of 25a squared, which does simplify then down to 5a plus 3 times the square root of 5a, and that's it. All right, so we can simplify using FOIL as well. If both radical expressions have 2 terms, you can use FOIL to find the product. And I hope you guys all remember FOIL. So it's the first 2 multiplied together. It is the outer 2 multiplied together. It is the inner 2 multiplied together, and then the last 2 multiplied together. All right, so we have 2 times the square root of 6 times the square root of 6 plus 2 times the square root of 6 times negative 5 times the square root of 3 plus 3 times the square root of 3 times the square root of 6 plus 3 times the square root of 3 times negative 5 times negative 3, or times the square root of 3. So let's go ahead and simplify all of this. So the square root of 6 times the square root of 6 is the square root of 36, which is just 6. And then we're going to combine some terms there, combine some terms there, combine some terms there, and now we can start simplifying. All right. Oh, and the square root of that's this right here. That's that right there. Okay. So moving on. Oh, okay, so 12 plus negative 7 times the square root of 18 plus negative 45 That's 9, pulls out the 3. There we go. All right, all done. All right, and just remember special products. These are things that you should remember from a while ago. A plus b squared equals a squared plus 2ab plus b squared. This might make your life a little easier, and you're just using radicals. And the cool thing is when you have a squared and b squared, and you have a radical there as a and b, it means that the radical will cancel out and leave you non-radical situations. Yeah, so we have the square root of 7 plus 4 squared. So we're going to end up with square root of 7 squared plus 2 times the square root of 7 times 4 plus 4 squared. Check that out. Pretty easy, huh? So use those special products that you learned back in chapter 8 to help you out now in chapter 10. All right, so conjugates. Conjugates are sums and differences of the same two terms. So the square root of 5 and the square root of 2, if you plus them, is the sum version of the conjugates, and if you subtract square root of 5 and square root of 2, you get the difference of them. All right, so the product of two conjugates, in this case it would have been square root of 5 plus the square root of 2 times the square root of 5 minus the square root of 2 will give you the difference of squares, which is another special product. Again, chapter 8 is never going away, guys. All right, so let's go ahead and look at notice how the product of these conjugates would not contain a radical, because basically you're squaring both of them to get rid of both of them, which is great because we can use it to rationalize denominators. So we use the conjugates to rationalize denominators that have two terms. All right, so here we have a rational expression, and we need to rationalize it so that there are not radicals in the denominator. So I'm going to multiply this by the conjugate of the denominator, the difference of the denominator, and it's basically going to cancel some stuff out. And distribute, and there we go. 5, square root of 7 squared is 7. The square root of 5 squared is 5. 7 minus 5 is 2. And then we can simplify. And right there, right here, that simplifies down. And then we can distribute, and then we get our final answer. Bam. All right, next problem. Negative 4 over the square root of 10 plus the square root of 8. I'm going to multiply by the conjugate, and I'm going to get this and that. I'm going to simplify, right there, simplify. And then I'm going to end up with that. But I can simplify further because I can pull out a square root of 4, and that leaves me with that final answer there. So again, guys, it's a lot of work. It's a lot of boring work, but get over it. All right, next problem looks like that. So I'm going to multiply by the conjugate. The conjugate's going to cancel out my denominator. It's going to allow me to simplify, but I now have a fraction, but that's okay. I'll just distribute the fraction. Woo! Final answer, done. All right. Now, how do we apply this? Application. Well, the ratio, which is length to width, of a painting by Mondier, or however you say his name, it's a pretty cool painting, you should Google it, is approximately equal to the golden ratio, which is 1 plus the square root of 5 to 2. The length of the painting is 81 inches. We're going to find the width in simplest radical form, which is the exact answer, and then we're going to find the approximate. So if ever you have pi or radicals or anything like that, you can find the exact width by just not doing the math. And then you can find the approximate answer by doing the math and rounding. Okay, so we know that the length is 81, the width is x, and that we know that it is related to the length to width of the golden rule, which is 1 plus the square root of 5 to 2. So then I'm going to make myself some equivalent fractions. We know that the length to width ratio of the golden ratio is here, and we know the approximate the dimensions of the painting. Well, in this case, we actually only know the length, and we've assigned a letter for the width. So now we're just going to go ahead and do cross product, which is going to give me x times 1 plus the square root of 5 is equal to 81 times 2. So if I keep going and simplify, now I need to divide by 1 plus the square root of 5 so I can get x by itself. And then I need to rationalize the denominator to simplify it further. Again, can't have radicals in the denominator currently. Later on in math, you're going to be like, Miss GH, we don't care anymore. But for right now, we care. All right? So we rationalize the denominator, and we get that. We're going to simplify it, and we're going to get that, and simplify again, and we're going to get that, and then that is actually the exact answer, because there's nothing more you can do. But if we do the math, we're going to get the approximate answer, which your calculator can gladly help you with. All right, I'm done. Hey, 10 minutes. Bye.